Hi everyone, my name is Azri and today I'll be presenting on modern technology solution for improving environmental sustainability in the fertilizer manufacturing industry, building on the industrial chemical safety analysis from my written report. As a quick recap, my report focused on the ammonia-based fertilizer manufacturing industry, using the 2016 ammonia gas leak at Petronas Chemical Fertilizer Sabah plant in Sibitang as the case study. The core process involved the Haber-Bosch reaction, where nitrogen from the air is combined with hydrogen, typically derived from the natural gas under high temperature and pressure. This process ammonia, which is then either distributed directly as fertilizer or further processed into urea. Key operations include reforming, ammonia synthesis, storage, and urea conversion. Each one energy intensive and involving hazardous chemical handling. This process carry four main environmental impact. First, air emission. During normal operation, the reforming process burn natural gas and release carbon dioxide into the air. But during accident, such as ammonia leaks, the toxic gas is released directly into the atmosphere. Second, water impact. The production process creates wastewater that is rich in nitrogen. If this water is released untreated, it can harm river and aquatic life. So it must be carefully treated before being discharged. Third, waste. This includes leftover byproduct from the production process and during emergency, water that become contaminated after being used to dilute ammonia leaks. 4. Energy. The Haber-Bosch process need a lot of natural gas, not only as a raw material to produce ammonia, but also as fuel to generate the heat that the process required. This makes the whole process very energy intensive. So, from this process, I identify three critical environmental issues. First, uncontrolled ammonia gas release. As seen in the Sibitang incident, leak during commissioning or operation release toxic ammonia directly into the air. The source is typically equipment failure, such as fault valve or valve failure, combined with insufficient real-time monitoring. Second issue, high carbon emission from natural gas reforming. The source is the reliance on fossil natural gas as the hydrogen feedstock for ammonia synthesis, a process that is fundamentally carbon intensive using conventional method. The third issue, inadequate emergency water management. As shown in the 2023 Shah Alam incident, facilities sometimes resort to ad hoc water dilution during leaks, which can introduce contaminated runoff into drainage system without proper containment. So, the first modern technology I propose is digital twin technology, specifically for virtual commissioning. A digital twin is a virtual replica of a physical plant, built from real-time sensor and engineering data. Before any new pipework or equipment is brought online with live ammonia, engineer can run the entire commissioning sequence inside the virtual model first, testing pressure change, valve operation, and even simulating leak scenario, all without any physical risk. This directly addresses first issue in the Sibitang incident. the leak occurred during real physical commissioning, meaning any undetected defect was discovered the hard way through an actual gas release. With a digital twin, the same commissioning sequence is validated virtually first, allowing engineers to catch well defect, pressure anomalies, or unsafe operating sequence before a single worker is exposed to a live ammonia. Next, the second technology is drone-based optical gas imaging, or OGI. These drones are equipped with thermal and infrared camera that can visually detect gas leak invisible to the naked eye. By capturing the temperature difference created by escaping ammonia, drone can fly pre-programmed route over piping, valve, and storage tank, especially during high-risk activity like commissioning, without requiring any worker to physically approach the area. This also addresses first issue, but from a different angle. Instead of waiting for a fixed sensor to detect gas at one location, a drone can visually scan an entire commissioning area from a safe distance, identifying exactly where a leak originated in real time while keeping every worker out of the hazard zone entirely. So together, these two technologies create a layered safety and sustainability system addressing risks at two different stages. Digital twin technology provides the preemptive layer, catching defect and unsafe sequence before a single drop of ammonia is introduced during commissioning. Drone-based optical gas imaging provides the real-time visual layer, scanning physical operation and detecting leak the moment they occur without exposing worker to danger. The sustainability outcome is threefold. Fewer uncontrolled release protect air quality and worker health. Visual commissioning reduce waste material and rework from physical trial and error. And remote drone inspection reduce the need for emergency water dilution response that generate contaminated runoff. This demonstrates a clear connection from the industrial process to the environmental problem to the technology solution to a measurable sustainability outcome. So the conclusion is integrating digital twin visual commissioning and drone-based optical gas imaging into ammonia fertilizer plant can directly prevent incidents like Sibitang, while simultaneously reducing the industry environmental footprint. So that's all from me. Thank you for watching. Assalamualaikum.